Welcome to the week 10 maths graded assignment solution video. So this particular week is the most of the content for this particular week is from DSA, data structure and algorithm, but IITM is teaching us in the math section. So whatever, let us start with the first question, that is the maximum number of non-zero entry in an adjacency matrix of a simple graph having n vertices. So there are n vertices in a graph. So let us start with 1. Since in the lecture they start with 0, but for solving this particular problem we should start with 1 and then it will go up to n. The rows will also go to n. All the diagonal element will be 0. Because the edge between 1 and 1 is not valid. Okay, so in the graph theory 1 and 1 is not considered as a edge. Okay, so all the diagonal elements will be 0. So it implies the total number of entries will be n square, and we have to subtract it all the zeros. So it will be equal to n. So it will be equal to n into n minus 1. This particular problem can be solved also by using some basic concept. Let us suppose there are n elements 1 to n. So for this particular element 1 there will be n minus 1 option available. Similarly for 2 there will be n minus 1. Similarly for 3 it will be n minus 1. So up to n it will be n minus 1. So the total entries will be equal to n into n minus 1. The second question asks about which of the following is a possible listing of the degrees. Okay, so we have a graph which has 6 vertices. So from the given option we have to choose which degrees can be valid for this particular graph. So before solving this particular problem we know the summation of degrees of all the vertices is equal to 2 times the number of edge. So that means the summation of degree will be always be an even number. Okay, so now moving to the option. For the first option the summation of degrees is 6 plus 5 plus 4 which is equal to 15 plus 6, that is 21. So this option will be ruled out. The second option is 5 plus 5 10, 14 and 2 16. The third option is 5 plus 3 plus 3 which is 11 plus 4 15 plus 1, this is 16, and this is 2 1 2 3 4 5 5 plus 2 is 7. So from the given option the first and the fourth one will be ruled out. Since the sum of degrees is 16, so this can be valid degree of the graph. So let us try to recreate this graph. So now let us try to generate the graph for the second option. There are 6 vertices. Let us suppose these vertices are 1 to 6, 1 2 3 4 5 6. Okay, so let us draw. So let us suppose the degree for 1 is 5, so it will be connected to all the other vertices. So it is 2, 3, 4, 5 and 6. So now there is another term which has degree 5, so it will also be connected to all other terms. So let us suppose the degree for 2 is 5, so connect with all other terms. So the degree for 1 and 2 will become 5. So now let us think about the other terms, that is 6, so its degree is 2. For 3 its degree is also 2. For 4 its degree is 2. For 5 its degree is also 2. So for the second option we are not able to generate a graph. So now moving to the third one. So the first degree is 5, so let us suppose in this particular case for 1 it is 5, so it will be connected to all the other elements. So this is 4, this is 5, this is 6. So for 1 its degree is 5, so there is another 2 term which has degree 3. So now for 2 its degree will be 3, 1, 2, 3, and for let us suppose for 6 its degree will be also 3. So there are 2 terms which has degree 2. So for 5 and 3 its degree is 2, and for 4 its degree is 1. So in this particular case we are able to generate graph for the third option. So this option will be correct. So this option is ruled out, this option is also ruled out, and this option is also ruled out. So for the second question the third option is correct. So for the third question, this statement given is the proper definition of depth first, DFS. The statement given coincides with the statement for DFS. So in depth first search we use a stack. So for this particular question the correct answer will be the second one, a stack. So the question number 4 asks about the adjacency list with respect to incoming edges of the graph G, whereas the forward edges are given in the adjacency list, and we have to find the adjacency list for incoming edges. So first we will draw graph for it. So for 1 its edge is going to 2 and 4. Now for 2 its edge is going to 3, 5 and 6. Now for 3 its edge is going to 7. Now for 4 its edge is 3, 5 and 6. So 4 is equal to 5, 6 and 7 as well. So for 4 its edge is going to 3, 5 and 6. For 5 its edge is going to 6 and 7. So its edge is going to 6 and 7. For 6 its edge is going to 1. For 7 its edge is going to 1, 2 and 6. So for For 7 its age is going to 1, 2 and 6. So we have to find the adjacency list for incoming ages. So we will draw adjacency list. So here we will write 1, 2, 3, 4, 5, 6 and 7. So for 1, only 2 elements are there. The incoming ages are from 6 and 7. For 2, the incoming age is from only 7. For 3, its incoming age is from 4, 2, 4 and 2 only. For 4, its incoming age is from 1, 1 only. For 5, incoming age is from 2 and 4. For 6, its incoming age from 2, 5 and 4 and 7. And for 7 it is 3, 5, 3 and 5. So this is the particular adjacency list for incoming ages for the graph G. So based on the option given, our list matches with so 4 to 1 is also left here. So there will be 1 here. So based on the adjacency list, the correct option will be the third one. So the question number 5 asks about which of the following cannot be age in the original graph. So this particular problem can be solved using the first in first out method using labels. So the 1 will be the first one, then 5, 4 and 10. After that it will be 6, 11, 3 and 12. After that it will be 7, 2, 9, 13 and the last will be 8 and 14. So now we will draw the label. So from here to here it is level 1. From 5, 4, 10 it is level 2. From 6, 11, 3 and 12 it is level 3. And up to 13 it is level 4, and this is the last level, level 5. So for becoming an age in a BFS tree, the elements should be from either from the same level or the second criteria will be either from adjacent level. That means if one element is from I, then the other element should be from I minus 1 or I plus 1. If there is an element which is in L2, then age can become from the level 1 or level 3. So based on this understanding, now moving to the option. The first option is 8 and 11. So it comes from the level 5. So level 5 and 11 is from level 3. So level 4 is missing here, so this can't be true. So the second is 3 and 10. So 3 comes from level 3 and 10 come from level 2. So this can be an edge in the graph. So the third is 4 and 5. So this comes from the same level, so this can also be an edge in the graph. And the last one is 6 and 9. So 6 comes from level 3 and 9 comes from level 4. So this can also be an edge in the graph. So now this question is asking about which cannot be an edge in this particular graph. So the 8, 11 cannot be an edge in this particular graph. Okay. Question number 6 is asking about we have to choose some graph based on the condition which has the minimal vertex cover should be 3, the perfect matching should be 3, and the graph is a 3 coloring. So when we find the minimum vertex cover, there is a very fine method to find it. So this particular question is application of the lecture number 2 in the week 10. So the property is the complement of minimum vertex cover is the maximum independent list. Okay. So maximum independent list means the cardinality of that list will be the most. The cardinality of that particular list will be the maximum among all the independent list. So let us try to rename these vertices. So it will be 1, 2, 3, 4, 5 and 6. So write down all the vertices 1, 2, 3, 4, 5, 6. So the independent list will be, first we will choose 1. So write here 1, remove 1 from this list and its neighbor, so which is 2 and 6. So now move to the second element, which is 3. So remove its neighbor, so 3 will be removed, so its neighbor are 4 and 5. So there are only 2 elements in the independent list. So the complement will be 1, 2, 4, 5 and 1 should not be there, 2, 4, 5 and 6. So the minimum vertex cover will require 2, 4, 5 and 6, which is equal to 4. So this option will be incorrect. So now for the second one, so let us rename its vertices as 1, 2, 3, 4, 5 and 6. So this